Am I allowed to sit there?
Yes.
I just took it out of the paper.
All right, number 16 on our homework. Ooh, yes, the congruent triangle one. So congruent figures have to have the same shape, same size. So our angles need to be the same and our sides need to be the same. Now we can pretty easily count this side, it's 3, and this side is 4. Now what type of triangle is this? A right triangle. So I need to have side lengths of 3 and 4, and it has to be perpendicular between them. And then technically we can find out our hypotenuse. What's our hypotenuse? Something else. 5. It's 5. Good. So I'm looking for a 3, 4, 5 triangle. All right. Now you could go through and find the distance of each one, or you can plot it on your graph and count. So when you plot on your graph and count, when we do A, we have 0, 0, 3, 4.
Yeah, that's what I did.
0, 5. Now I have 5 there, but it's not easy to count if that's 3. It's not easy to count if that's 4. So let's take a look at our angle. Is that 90 degrees? Perpendicular lines have what type of slopes? Opposite reciprocal. When we find our our slope for this guy is up 1 over 3, negative 1/3. Our slope for this guy is 4 over 3. Are those opposite reciprocals? No. So it's not it. Alright. Let's check for B. B is 0, 0, negative 5, 0, 0, 4. Hey, we've got a right triangle. So this is side length 5, this is side length 4. It was 3 and 4 that were perpendicular.
So wrong side.
Wrong sides. When we do C, negative 1, 1, negative 4, 5, and negative 1, 5. Okay, we've got perpendicular. Now let's count it. That's 3, that's 4. Alright, so that was number 16.
I love you.
Let's next go to number 14. Alright, number 14. It says reflected across the x-axis and then reflected across the y. They want just A prime. So I look at my A, reflected across my x-axis. Let's go 1, 2, 3, 4 above. So we go 1, 2, 3, 4 below.
Oh.
And then reflect across the y-axis. It's 1 away, so I want to go 1 away. And this is negative 1.
I was right.
Negative 1.
Oh, that's so easy.
Wow.
Wait, what? No, I thought you got
Yeah. So across the x-axis, it's 4 away from my x-axis, so I go 4 away below. And then across my y, it's 1 away to the right, so I want to go 1 to the right. You just counted your coordinates. Maybe you need to fly.
What? Wait, what?
Alright, so that was 14.
Oh, yeah.
Let's go next to 7. Yes.
Because I don't really remember what
Ooh, line of symmetry. Who can explain a line of symmetry?
Me.
Connor.
Where it splits the shape in half into two congruent shapes.
Splits into 2 congruent shapes. So basically just folds it in half to do the same thing, kind of like a butterfly. So I want that to happen twice. Just once. Once, if I tried this way, that doesn't go exactly down. 1, 2. That one's just 1.
I got it.
Let's go.
No, don't you dare go. Wait, what's after? Yeah. Yeah. All right.
Oh, Wait,
Is this the time up next to Q?
Yeah.
Okay, let's go to 3. Alright, number 3, the question was on this.
I'm fine.
Brent takes a vacation. Q represents Brent takes a vacation.
3.
So Q. Any other questions on 3?
How'd you get the Q?
Oh my gosh, I did.
Brent takes a vacation. Q represents Brent takes a vacation. So it's
You
Q.
got negative Q.
He takes the vacation.
Yeah, I know.
If he didn't, then it would be.
Then it'll be
Alright,
Just regular Q.
let's go 4, and then 5.
Oh yeah, this was supposed to be. Oh, I did not.
Ooh, number 4, our construction one. Alright, for number 4, our construction, our process that is shown is that they did same thing, and then they measured and marked it. Now this is the process for copying a name. If we were to go ahead and connect those, that would be copy name. Now let's suppose you completely forget how to do your construction. How can we get to our answer? Do they bisect the angle? No. Angle congruent? Possible. Line segment congruent to a given line
What do you
segment.
mean by angle congruent?
The 2 angles are congruent.
What 2 angles?
This angle and this angle.
The 90 degrees.
So when you connect that in, this is what's the construction show.
Oh, these.
This would be number 4. I thought it was like a step 1 and step 2, and I was really.
Yeah, that's what I thought it was, and I was like, why'd you erase the line?
Yeah. All right, I got it right. So line segment congruent to a given line segment. Number we're working with an angle here, and then I'm guessing most of you got maybe D. So we've at least got down to 50-50 shot. Now let's talk about D. A line segment perpendicular to a line segment. All right, we talked about when we did our constructions. Okay, I'm going to use my fingertips after my compass. For going perpendicular, we would go and then come here. So we have little marks like this. Oh, I did that wrong.
Yeah.
That was our perpendicular, a very rough thing. But also too, there's nothing here that indicates we did perpendicular.
There's no underlines.
Yeah. So no. But this is the 2-step process for copying angle that we did. You draw an arc, measure the width. Okay, and then 5 was another one we wanted to see. Alright, so we've got parking spaces. Which diagram could be used to show that AB and CD as well as AC and BD? So we have both sets are parallel. Alternate interior, congruent. Alternate exterior, congruent. Same side interior, supplementary. What's the other congruent? Corresponding. Good.
That has to be.
Alright, so I need to have that it shows congruent or shows supplementary for both sets of lines. If I take a look at A, I've got alternate interior. Sweet, that takes care of A, C, and BD. Is 125 and 55, what does that add up to be?
180.
180. Could that be helpful for us? Okay, so if this has to be 180, oh wait, that's still the same lines. Man, bummer. Okay, C. We've got corresponding, awesome, that takes care of these lines. And the supplementary, oh wait, that's the same set of lines.
Oh.
Here, alternate interior, yay, that's this set of lines.
Same side.
Same side interior, hey, we got another set of lines here. And let's just double check D. Same side interior, alternate interior, same side lines.
Oh.
Okay. Let's see what else we need. Alright, 8 and 10.
Hold on, let me check. Where am I at? Yeah, I don't get 8. I guess.
Alright, I'm gonna look at 10 first, actually.
Oh, wait. But I know what the 8 is now.
Alright, so number 10, another construction one. It looks like it's talking about segment AB. So here's segment AB. Alright, a bisector of AB. Bisector means it does what? Cuts in half. I connect this. Does that cut that in half?
No.
Line segment congruent to AB. Is that congruent? No. Perpendicular to AB through E. No. Doesn't even go through E. Perpendicular through G.
Oh, let's go.
I was right.
Okay. Now our remaining questions that we have, looks like there are just a couple people that have those. So next we're going to take a look at our answers for our rotations. We're going to look at our answers for rotations. If you are one of these lingering people, raise your hand so I can come answer those specific ones while you guys check rotations. Anna, did you finish your problems?
Yes.
Alright, I'm coming back to you. Good job.
I would have looked to that one.
Oh, you got to
I know.
I'm not confident I'll be able to. Alright, check your rotations. Yes.
Wait, what you guys gonna do?
Number 3, I did like 5 times and I couldn't get it. So can we do number 3?
Sure. Alright guys, let's take a look at number 3.
I did 5 points instead of 4.
No.
I would love for everyone to stop talking.
Oh, yeah, right.
Everything.
I
Our Excel review units 1, 2, 3, and a little bit of transformations. Alright, so number 3, I'm just going to go and use number 3 as our example of how to do this as a refresher for those that struggle. Obviously, if you visualize, you can do visualize. I'm going to talk about how to use our rule here. Some people just have skills, trust them. I can't see that. Same here. I have to go back tomorrow. Okay, our rule does not make you have to worry about what quadrant you're in. So we are always starting with this right here, regardless of which quadrant you started in for your points. So I'm trying. You with this? Yay! Okay. So it doesn't matter which quadrant you're in. This is our starting point. I only use this setup to let me know 90 degrees uses what? 180 uses what? So number 3, it says 90 degrees clockwise. So if I'm starting here, which one is 90 degrees clockwise? Right here. Good. This is my 90 degrees clockwise, so this is the rule I'm using. XY becomes Y negative X. So that's the rule I'm using. I'm going to write that. So this one becomes Y negative X. Alright, so I'm going to write my new points. B, we have as the point 1, 2, 3, 4, 5, negative 5.
I don't get how.
So I'm going to take this. Who am I looking for? So my B prime, I want Y. My Y was 1. I want opposite of X. Opposite of X would be 5. That's right. Okay.
How did you?
And then you just repeat that for each one.
I think I messed up the clock.
That will affect it.
It's
Now, my recommendation to you guys is to connect as you go. So I'm going to graph my B prime, and then the next one that I do, I'm going to go ahead and do F next. So F was the point negative 1, 3. So when I do F prime,
I got that one right.
I want my Y value. I want my opposite of X. So now when I draw 3, 1, go ahead and connect those so you can start to see the shape coming together.
I got all of them
It's
right.
going to help you eliminate problems from having too many lines.
Miss, how do you know like to like when you say go clockwise 90 and it's supposed to be into the fourth box? Why is it not in the fourth box?
It's not in the whole thing. It's going to be the fourth box.
None of those.
This is in my second quadrant, so clockwise 90 would put in the first quadrant.
I didn't know.
90 takes you just
Oh, so for M, H, you have to do different numbers?
Yeah, so M is going to be in your third quadrant, so it'll finish in your second. But you're not using a different rule, you use the same rule.
Is this gonna be on the?
Our rule only tells us, that you don't have to worry about your location for the rule. You just decide your rule based upon how much you're doing. We did 90 degrees clockwise, that means use this rule.
Ah, so you don't know.
You don't have to worry about where it is, the rule will take care of that.
Oh, that makes more sense.
Okay,
No, it's the transformation and destruction.
All right, go ahead and check 5 and 6.
It's in the quest. It's in the quest.
Where's the one? Yeah.
It's 5 or 8.
I got the marker. No, I didn't even do that
You
one.
think this one is in 1, 2, and 3.
There's no 17 that way. Alright. Go, I got the
Now for 7, 8, 9, and 10, you just wrote out the coordinates. You don't have to actually draw it. If you're a visual person, you can draw it, but it's easier if you just remember your rules. Let me zoom in on those for you.
I got them all.
Andrew, can you stop talking to Adam? You've been talking to him for about the entire class. Please stop distracting him. I'm sure it's going both ways, but you're just one that I see whose mouth is moving.
Exactly.
Yeah, my bad. I'm sorry.
Well, I want to see.
No matter what quadrant, whether it starts in the fourth or the third, you always do X, Y as the base, and then
Yeah.
that makes it a
So
lot worse.
ignore your location. That setup for my rules has nothing to do with the location.
Okay.
It just allows me to visually think 90 degrees is this, 90 degrees is that. Okay, and then 11, 12, 13, and 14, you were just writing a rule to describe it. So we're not doing X, Y maps onto something. You literally just write 90 degrees clockwise or counterclockwise.
Well, for the first one, wasn't it?
So they're just opposite. So for quadrant 1 and quadrant 3, they're just the opposite. And then
Yeah, just opposite signs. Okay, now you could have had different answers. You could have said rotation 270 degrees counterclockwise. You could have said just rotation 270 because our default is counterclockwise. You could have said rotation negative 90. And then these other ones aren't very exciting because they're 180. Yeah, doesn't matter which direction.
Negative
It's
180.
easy. We changed it.
wait, let me see.
Okay,
Wait, when did you get 1?
other questions on our rotations? It's really important to remember the rules.
So something in for homework, will it be on this thing, or is it because it's new content, there'll be a separate
Could
way
be
for
on
it? Okay.
Wait, oh, I see this. This paragraph.
No, this does not show what it means for lessons.
Yeah. No.
Yeah, so we're determining rotation. So easy, just talk out.
Oh, fairly Friday.
Okay, so our review.
You have to say about the origin now. You have to say about the origin.
Could be,
This paragraph.
could be on any of them.
You have to say about the origin.
You should. Not only go about the origins, but you don't have to behind something. Okay, so what we have left is we have our transformations topic for today, and we have our SWL quiz. The transformations topic for today is pretty simple, actually. You're gonna look at me like, why am I teaching you kindergarten material? But it's still good for us.
I wish.
I think it's about like that. And it's also going to recap our previous transformations. So we're going to do that first and then our SWL quiz.
What is there to be like extra about at this point? All this new material.
Or we can just back after every class room.
If everyone were to be present, but when people are absent, I can't give it back.
What is this?
This is the note.
The calculator's not like connected to a cloud to get something like the calculator's
Okay.
It's better if I double check
Is
it.
there anyone that did not get a German Shepherd? You got an extra. Okay, So our transformations today are pretty simple, nothing too crazy, a little bit of recapping, a little bit of new. Alright, so we already talked about line of symmetry. Line of symmetry if the line cuts the figure into two congruent halves. So like we said, if you fold it in half. Oh, okay. So it's like if you fold in half, kind of like a butterfly. Same exact thing on either side. So our German Shepherd, because he is perfectly symmetrical, this one.
All German Shepherds?
I don't think so, but this one is. So we've got one line of symmetry there.
Okay, one extra here.
Now our H has two lines of symmetry. This is a regular hexagon. How many lines of symmetry does the regular hexagon have? Like 12.
A lot.
6 or is it 12?
Six.
12. It's 12. It's 12. Kyle, what did you say?
I said 6.
What was your response to the 12 people? Because you gave a funny face.
Well, I was
They are lines, right?
Lines, yeah, so they have to go all the way through.
Yes. These are lines that go all the way through. That's one line of symmetry. So how many lines of symmetry does our hexagon say? Okay. So you cut the entire shape. So there are 6 lines of symmetry for a regular hexagon. Okay. Yes.
For the H, can you just like cut it and like diagonally?
No. We try to do it this way. This. It's like that.
Because you added that once.
Cool.
You can do it.
So this
This
part
Not even close.
sticks out like that.
Yeah.
Oh.
This. It's like okay. That makes sense.
Oh.
Go ahead. Okay. So now for our symmetry below this. Okay. We have point symmetry and we have rotational symmetry. Rotational symmetry simply means that when we rotate it a certain amount, it's the same figure. So our pinwheel here, would you agree that if I rotate it 90 degrees, we get back the same figure?
Yes.
Okay. So it has rotational symmetry of 90 degrees. Now, point symmetry, see Adam, now I see that you're the one talking, Ken, don't distract.
See?
Point symmetry is if I turn it 180 degrees, is it the same thing?
Yeah.
Sure. Does this one have point symmetry?
Yeah.
Turn it 180. Is it
Yes.
the same thing? Yes. If you turn the paper upside down, is it the same thing?
Yeah.
So it also has point. So point is only 480 degrees. Rotational is for any degree 180 or
Also
less.
has point.
Also has point symmetry. I forgot my symmetry. Alright, so our king of hearts here. Can I rotate him 180 degrees or less and get back the same thing? Yes. Yes. So he has rotational symmetry. What degree does it take? Yeah, it takes 180 degrees to get him back. So does he have point symmetry?
Yes.
Yeah. If he has 100 degrees rotational, he automatically has point. Alright, how about our hypnosis over here? Rotational? Yes. How much for rotational? 180. Good. So then does it have point? Yes. So rotational symmetry is any if you can rotate it 180 degrees or less, and it's the same thing. Point symmetry, check. 180 is the same thing. Okay. Let's take a look back at our German Shepherd. Does he have rotational symmetry? No.
No.
Does my H have rotational symmetry? Yes. Yeah. How much? Point.
180.
180, which means it does have point. Now how about my regular hexagon? Does that have rotational?
Yeah.
So what is the smallest angle it takes to map it back onto a
90. 45.
60.
90, 60, and 45.
Okay, wait, I know 90 works, but I don't know about that.
How much does it take to take this edge to this edge here?
60.
60. It's this triangle, which is 60 degrees, to go to this triangle. So it's 60 degrees. My rotational symmetry for this would be 60 degrees. Does it have a point? Yeah.
Yes.
Yeah. If I flip it 180 degrees, does indeed. So another way you can think of point is that if your rotational symmetry, if 180 is a multiple of it, what's going to happen? 180 is a multiple of 60. All right. The bottom is just a lot of the same stuff. We already did it, not good. Let's move back.
That's complicated. Well, it's that.
All right, transformation. This is a change in size, shape, or position. Alright, now this is just going to be recapping because we've already done this before. Transformation, we use an arrow. We say triangle ABC maps on a triangle PQR. Our original figure we call the pre-image. You'll hear me use that vocab word, the pre-image. Now our final thing is the image. So our pre-images are starting, the images are final. And it's more common that instead of having different letters, we would say triangle A prime, B prime, C prime. We can have the different letters, but the prime is more common. Okay, so down below are the transformations that we have. Our first one is called a translation. Changes your position, so that'd be a slide or a shift, left or right, up or down. What do you think our second one's called? Reflection. Reflection. So change your position. You think of flip for that. Our third one? Rotation. Rotation. I think that's the hardest one of the transformations. And here we go, clockwise or counterclockwise. Think swivel for that.
Which one is that?
Rotation. Who knows what the last one is?
Dilation.
Dilation. Dilation is where we have a change in size. Notice my pre-image, the starting one, and then my image is the final one with the prime.
Oh.
From my pre-image to my image, it got larger, got twice as large, so scale factor of 2. Okay, and then this word isometry we've already talked about before. We never formally wrote it down. An isometry, so a transformation. Transformation. I mean, my vocab I know, just like you should know your vocab. A transformation where the pre-image, so our starting, and the image, so pre-image and image, so our starting shape and our ending shape, what's true about them? Good. So we have 4 transformations. 3 of them are isometries, 1 of them is not. Which one is not an isometry? Dilation. And I'm pretty sure you already did the bottom for homework at some point in time. Which one of these is not an isometry?
The middle.
And that's it for our transformations for today. Again, pretty easy. Really, the only new thing was that rotation. Now, your homework for tonight, remember there's 3 parts to it. First part, worksheet, practicing your transformations, coming at you. Second part is March Madness. Third part?
SOL.
Oh yeah, sorry, May Madness. We're in May.
SOL.
SOL packet. I don't think you have as much on the SOL packages. It's your homework.
I'll go to kitchen with the water.
Okay, just a moment.
Yes, where can it be?
Oh, snap.
Alright.
What is your slice? Would you like this?
I was just
I don't blame you. No. All right, we'll now transition to our quiz. So you can go